Okay, today we're going to review feedback loops. But before we can really get into feedback loops, we've got to explore what a system is. And so we need to think about three types of system. We've got open systems, closed systems, and we have isolated systems. Okay, now the thing about systems in ESS is that we're talking about flows of energy and we're talking about flows of matter. Now, in an open system, you have energy entering the system and you have matter entering the system. But you also have that energy coming out of the system and you have the matter coming out of the system. That means that there's an open system. You've got inputs and you've got outputs. Okay? And that's the vast majority. That's the majority of the systems you're going to come across. Now, you've also got closed systems, and in closed systems you have energy coming in and you have energy going out, but the matter doesn't cross the boundary of the system. It stays there inside. And these ones are either created by humans as experimental experiments, but also you can think about the global nutrient cycles as more or less closed systems, because we don't have any more water, nitrogen, phosphorus coming into our system. It's all there inside the system already, and so that's why we're concerned about managing those things. And then an isolated system, well, this is a scientific, a theoretical idea. I mean, it could be the whole of the cosmos, the universe, but in this one, all of the energy and all of the matter is inside the system and it stays inside. It doesn't cross the boundaries. Okay, so what we're going to now look about is how does those systems maintain themselves? How do they maintain stability? Or what happens if they don't maintain stability? A system is going to hopefully have some kind of equilibrium. Okay, and that's the ideal situation for an ecosystem, which is what we're really considering. Okay, so first of all, we're going to think about how these systems maintain that equilibrium, and so we're going to think about negative feedback. And remember, negative is good. Okay, this is a negative feedback loop. Okay, so we have to think about a definition for negative feedback, and what happens is that when an output of a process the output of a process actually inhibits or reverses that process. Okay, and so what's happening is that it's going to feed back and create a loop that inhibits or reverses the change. You can say that it counteracts deviation. That's one way of talking about it. It increases stability, and it returns a system towards that equilibrium. Okay, so that's negative feedback. But that sounds a little bit theoretical, doesn't it? So we need a nice example. And when we talk about examples in our ESS exams, we really want to be talking about environmental examples. You'll learn about lots of negative feedback loops in other subjects, like biology particularly. So in biology, you'll learn about homeostasis, that keeps the body in a stable, safe equilibrium. But we want to look at environmental examples. So the classic example for ecology is the predator-prey relationship. Okay, and so we can talk about the numbers of let's say that this is the prey. This line indicates the prey. Now, what's happened is that the prey numbers are increasing, okay, because there's more food available. So what happens alongside that is that the predator numbers increase. But at a certain point, the predators have eaten so much of the prey that inhibits the size of the population of the predator, and that decreases. And so the prey numbers increase, but then the predator numbers can increase. And it goes very much in a cyclical fashion. So this is the predator number. Now, to score marks in your exam, when you're talking about this, there are some key things that you have to talk about. You have to say that the prey increases as food is abundant. There's lots of food, okay? And then, therefore, there is more food for the predators. And so the predator numbers increase. And now you're going to get to that inhibition piece, because the predators increase. The predators increase causes a decrease in the number of the prey. And then predator numbers decrease. Okay, what you've got to make sure you make clear is that there's a causal relationship. Okay, one thing is leading to another, and in this case it's maintaining stability. You're having an equilibrium in the system. So it's a causal relationship, and we can improve this further by talking about real examples. So you could say e.g., and the one that's in all the textbooks is the lynx, which is a really beautiful cat, and its prey is the snowshoe hare. Okay, and that's going to be a great answer. Now, often one example isn't good enough. So another really rich set of examples comes from global warming. And we're going to talk about global warming with a few examples because, as you might suspect, there's some feedback loops involved in global warming which can be very bad as well. So we're going to start with potential positive. We're going to talk about good things for the environment. So we're going to give negative feedback examples for global warming. Okay, so key again is that you've got to talk about the something that's changing. Okay, so there's more carbon dioxide in the atmosphere. This leads to a rise in global temperatures. Okay, now carbon dioxide is actually good for plants, and so what happens, what could happen, is that more carbon dioxide leads to more photosynthesis. So the photosynthesis in the plants is using up the carbon dioxide, and so decreases the carbon dioxide levels in the atmosphere, and then that leads to a decrease in global temperatures. That's the hope anyway. Okay, so that's an example of a negative feedback loop where the rise in carbon dioxide causes more photosynthesis and eventually decreases the photosynthesis level, decreases the carbon dioxide levels. Okay, so that's one example. Another example would be that you've got a rise in global temperatures, and that's leading to a increase in evaporation. which leads to more clouds, which means that there's less solar radiation reaching the Earth's ground, and so that actually ends up inhibiting the temperatures, and the temperatures therefore decrease. Okay, so that's another example, and I want to use that one because we've got this example involving evaporation. Okay, we're going to continue with the idea of positive feedback loops. And here we're going to try and get that trick again to remember that positive is actually bad. Okay, and so what positive feedback loops are they're what you call destabilizing loops. Okay, they destabilize that system that we're talking about. They amplify change away from that equilibrium. And so they can actually end up sending the system towards what we call a tipping point. But we'll come back to that idea. Okay, first of all, we're just going to get some examples of positive feedback loops. Okay, and we're going to use the global warming examples again. Okay, so we've got temperature increasing. It's getting warmer. Now that leads to ice melting. Now ice is highly reflective. It has what's called a high albedo. Okay, so that ice melting means that the albedo of the surface of the Earth drops, it decreases. And as albedo drops, then you're getting more solar radiation absorbed by the Earth's surface. And guess what? That leads to a temperature increase. And so here we have amplification. That's going to increase and increase. It's just going to keep on getting worse. Okay? Another example of a positive feedback loop in global warming is again temperature increases. The permafrost, that permanently frozen part of the northern and southern hemispheres, largely the northern and high altitude areas, the permafrost melts. And permafrost is frozen vegetation, and when it starts to slowly decompose as warmer temperatures occur, and also in the summer it traps lots of methane. And so permafrost melting, methane is released. Now methane is like the big bad daddy of carbon dioxide, and methane is a super greenhouse gas. And so I'm going to write that down, a greenhouse gas. And so when methane's released, guess what? The temperature increases. So we've got another amplification. There's lots of pluses, but it's bad. This isn't a good thing for the Earth. Okay, so there's some examples of positive feedback. Now I'm going to come back to this idea of tipping points. Okay, and we're going to draw a little diagram. In ecosystems exist in what you call alternate stable states, and we can represent this in this graph. Okay, so this is the first state. We'll just give it number 1, but you could call it whatever you like. And say there's a factor changing that is going to start pushing the system away from its equilibrium. Now, in a system that has resilience, then maybe we get negative feedback loops, bringing that system back down to its equilibrium. Okay, so maybe we have that negative feedback and bringing it back to a stable equilibrium. Maybe that factor keeps on trying to push it away from the equilibrium, but in a really resilient system, there's another feedback loop that brings it back. But all of these push factors, you can think about them as push factors. If they're sufficiently strong and they overpower the system, then at a certain point we've got all this positive feedback loops. They're pushing it away from the equilibrium, and at a certain point you reach a tipping point. And once we reach that tipping point, the system slides into a new alternate stable state. It's perfectly stable, but it might be very different from the first system equilibrium. And so the system finds a new equilibrium, but it's almost impossible to try and predict what that new equilibrium is. So an example of this would be coral reefs. We've looked at coral reefs in class, and coral reefs under stress of increased temperature and increased carbon dioxide dissolved in the water, so that there's an acidification of the water. It becomes a lower pH, so more acidic. Then corals expel their symbiotic algae, and you get a bleached reef, whereas here we had a healthy reef. And so that's still a system state. It's in equilibrium, but it's not in a very happy equilibrium. Okay, and then finally, although it's not on the syllabus, I'm going to remind you about that idea of trophic cascades, because it's a really lovely idea, and this is the one where one small change can have a, let's call it a domino effect. You know, if you've got the stack of dominoes lined up and you knock one down and it changes many things, it causes them all to so that's what this word cascade means. It's that one thing leads to many different changes. So we could also symbolize it like that. And in our ecosystems that we're interested in, then these are food web interactions and even landscape changes. With those wolves in the Yellowstone National Park, it even changed the way that the rivers flowed and the distribution of trees. Okay, so I hope that's helped you with feedback loops.